On September 5, 1977, from Cape Canaveral in Florida, a spacecraft rose into the sky that would forever change humanity's relationship with the cosmos. Its name was Voyager 1. Built in an era when computers filled entire rooms and long-distance communication meant cables across oceans, Voyager carried with it technology that was cutting-edge for its time, but primitive compared to today's standards. And yet, this small probe would go on to become one of the most extraordinary achievements in human history. Voyager 1 was launched just weeks after its twin, Voyager 2. Together, the two spacecraft were designed to take advantage of a rare planetary alignment that occurs only once every 176 years. This unique window allowed them to use the gravitational pull of the giant planets as cosmic slingshots, gaining speed and saving fuel while visiting multiple worlds in a single journey. The original mission plan was simple yet ambitious: study Jupiter, Saturn, and their moons, then continue outward until contact was lost. But what followed was far beyond anything the mission designers had imagined. During its flybys, Voyager 1 revealed sights that no human eye had ever seen before. It showed us Jupiter's moon Io, where massive volcanoes erupt constantly, reshaping its surface in real time. It captured Saturn's swirling storms, massive systems larger than Earth itself, dancing in the planet's golden atmosphere. And it unveiled the cracked, frozen face of Europa, hinting at a hidden ocean beneath, an ocean that may still harbor life. Each discovery raised new questions and inspired missions that continue today, from the Europa Clipper to Dragonfly's planned journey to Titan. Yet, Voyager 1's greatest destiny was never confined to the planets. As it sailed onward, it became not just a planetary explorer, but a pathfinder into the galaxy itself. Today, Voyager 1 is more than 14 billion miles away from Earth, traveling through a realm no spacecraft has ever reached. Its signal, so faint it can be compared to the power of a single Christmas light bulb, takes more than 22 hours to cross the void and reach us at the speed of light. This fragile probe, powered by a small nuclear generator, has continued to operate far beyond its expected 5-year lifetime. Its endurance is nothing short of miraculous. In 2012, Voyager 1 made history once again. It crossed the heliopause, the invisible frontier where the solar wind from our sun collides with the interstellar medium, the thin gas and plasma that drifts between the stars. Beyond this boundary, the sun's influence fades, and the spacecraft entered true interstellar space. At that moment, humanity could rightfully claim its first step beyond the cradle of the solar system. But this step has not come without surprises. Voyager's instruments have detected signals that defy easy explanation. Plasma wave detectors have picked up unusual vibrations, structures, and tones that don't fit neatly into known categories. Some researchers argue these could be the signatures of exotic interactions in the interstellar medium. Others suggest they may reveal hidden structures, vast regions of dense plasma, magnetic fields shaped by ancient supernova explosions, or even evidence of matter we have never directly observed. One possibility that excites scientists is dark matter, the mysterious substance that makes up most of the universe but cannot be seen. If Voyager has brushed against its influence, it could mark the beginning of one of the greatest scientific revolutions of our time. And then, there are the more speculative ideas. Some patterns in Voyager's plasma recordings appear too structured, too orderly, to be entirely random. Could these be natural harmonics of the interstellar medium? Or, more daringly, could Voyager have stumbled upon signals not of nature, but of intelligence? The spacecraft may have passed through regions where cosmic signals converge, corridors of communication across the galaxy. Perhaps Voyager has eavesdropped on something never meant for human ears. The sounds of space recorded by Voyager are haunting. When translated into audio, the vibrations resemble ghostly tones, eerie and otherworldly, as if the cosmos itself were whispering. These sounds remind us that interstellar space is not a silent emptiness, but a living ocean of unseen currents and waves. Voyager has also revealed that the heliopause itself is not a rigid barrier. It shifts, flexes, and ripples like the surface of a great sea, pushed by both solar storms and the forces of the galaxy around us. Our solar system, it seems, is not an island. It is a participant in the greater rhythms of the Milky Way. Voyager 1, humanity's messenger beyond the solar system, keeping Voyager alive at such immense distances has become one of NASA's greatest technical challenges. The spacecraft was never designed to last this long, and its power comes from a small nuclear generator that slowly weakens each year. To stretch every remaining watt, engineers must carefully choose which instruments to keep active and which to shut down. Each decision is like choosing between senses. Do we keep Voyager's eyes, its detectors of plasma and particles, or its ears, tuned to the faint whispers of the interstellar medium? Every choice comes at a cost, and yet, despite its fragile state, Voyager continues to speak to us. But speaking across this distance is no easy task. Commands sent from Earth take more than 22 hours to reach the spacecraft, and Voyager's reply takes just as long to return. A full day passes before we even know if a simple instruction has been received. Communicating with Voyager is like sending a whisper across a canyon the size of the solar system. And yet, against all odds, Voyager whispers back. What Voyager carries with it, however, goes beyond science and data. Affixed to its side is the Golden Record, a copper disc coated in gold, designed to outlast the spacecraft itself. On it are sounds of Earth, waves crashing against the shore, birdsong at dawn, greetings in dozens of human languages, and music that spans cultures and centuries, from Bach to traditional folk songs. There are also images, encoded in analog form, showing our landscapes, our architecture, our families, our DNA. It is a time capsule of who we were in the late 20th century, a message in a cosmic bottle. The Golden Record was not meant for us. It was meant for whoever might someday find Voyager drifting through the galaxy, whether in thousands or even billions of years. It is humanity's way of saying, we were here, we dreamed, and we reached for the stars. Even if Earth itself is one day unrecognizable, Voyager will carry this memory forward, a silent ambassador in the dark. And Voyager's legacy is not confined to the past, it is shaping the future of exploration. Ambitious projects like Breakthrough Starshot, which proposes launching tiny spacecraft propelled by powerful lasers at a fraction of light speed, trace their inspiration back to Voyager. The idea that we can send messengers across interstellar distances is no longer science fiction. Voyager proved it could be done. Every new attempt to reach for nearby stars stands on the foundation this small probe created in 1977. For more than 4 decades, Voyager 1 has exceeded every expectation. It began by showing us the storms of Jupiter, the volcanic eruptions of Io, and the cracked ice of Europa. Later, it revealed the shifting edge of the solar system and the strange plasma tones of interstellar space. Time and again, Voyager has reminded us that the universe is stranger and more alive than we imagined. And even now, it continues to detect anomalies, structured signals, unexplained patterns, and rippling boundaries that hint at discoveries still to come. But nothing lasts forever. One day, perhaps within this generation, Voyager's nuclear heart will grow too weak. Its instruments will fall silent, one by one, until the spacecraft can no longer speak to us. When that day comes, it will not be the end of Voyager's story. It will continue its endless drift, orbiting no star, bound to no world, traveling through the galaxy for millions of years. Long after Earth's continents have shifted and its cities have faded, Voyager will still be out there, a lone traveler carrying our story. Voyager 1 is more than metal and circuits. It is the first of our creations to leave the solar system. It is humanity's first true messenger to the cosmos, proof that curiosity and imagination can reach across eternity. It reminds us that we are explorers by nature, that we dare to ask what lies beyond, and that even the faintest signals, born from a machine launched decades ago, can bridge the gulf between stars. And so, we are left with a question that lingers. What exactly has Voyager 1 discovered out there? Are its strange signals the first whispers of dark matter, the shadowy substance that shapes the universe? Are they signs of vast cosmic structures, unseen currents in the interstellar sea? Or, and this is the most daring thought of all, could they be echoes of intelligence, voices older and wiser than our own, drifting through corridors of space we are only beginning to understand? The answers may not come soon. They may take decades, centuries, or longer to reveal themselves. But thanks to Voyager, humanity has already crossed the threshold. We are no longer bound to the solar system. A part of us, fragile, persistent, and endlessly curious, is already among the stars.